Good morning, everybody. I think we will go ahead and get started now. Thank you all for joining us for this webinar. We're here to learn from New York school districts who are operating electric school buses as part of their school bus fleets. My name is Philip Burgoyne Allen. I'm a senior project manager at NYSERDA, where I work on our clean transportation team focused on electric school buses. But mostly today we're going to be hearing from school districts who are actually operating these buses in their own fleets. So first, I'll give a little bit of introductory information, but then we're going to hear from Perry Odie at Lakeshore Central School District and Varun Adibatla at the New York City School Bus Umbrella Services, or NYSERDA, and then we'll make sure to save time at the end for questions and answers from the audience. So first, just a little bit about New York State requirements for school buses. Currently, in order to improve air quality for students and reduce emissions statewide, New York has established a goal of having all school bus purchases as of July 1st, 2027, being zero emission, and by 2035, all school buses in operation after July 1st must be zero emission. This is a statewide requirement. It has not changed since the initial legislation in 2022 that put it into effect. You may have heard about waiver processes that will be rolled out by the state education department by the end of this year. While that is true, that 2035 goal for electrifying, or rather having the entire school bus fleet in the state be zero emission has not changed. So that's why we want to bring these school districts here on this webinar today so folks around the state can learn more from their experience. But first, just a little bit about the funding that NYSERDA has available. We have our New York School Bus Incentive Program, or NYSBUP, that has provided, it has available $500 million that has been allocated to support the adoption of electric school buses across the state. This funding is being delivered in three primary ways. We are helping school districts complete fleet electrification plans so that they have a sense of the next steps that they need to take, what the costs might be, what infrastructure is needed, and other things related to planning for electric school buses as they move forward in this process. And then we also have funding available for the purchase of zero emission school buses and for chargers in order to charge those school buses. So that is the overarching goal of the NYSBUP program. A little bit more about where we stand currently in the state. There are roughly 700 school districts in New York. There are more than 45,000 school buses on the road across all of the school district and contractors' fleets, and more than half of all those buses are contractor operated. We have made progress recently on the adoption of electric school buses. There are currently more than 100 of these buses on the road across the state, with more projected to be on the road within the next year, in part due to NYSBUP funding that school districts have applied for that will roll out on a rolling basis. Currently, more than 350 school districts are actively in the process of planning for their fleet transition with NYSERDA through the fleet electrification plans I mentioned previously. And right now, the average school bus in New York State travels about 80 miles per day, while most electric buses have a range of 150 miles or more. So what we're seeing is that many of the routes in the state are feasible with the current technology. So if you want to learn more about how NYSERDA is supporting school districts and contractors with the adoption of electric school buses, please visit our website. I've got the hyperlink there. And you can also reach out to us via email at schoolbus@nyserda.ny.gov. We will make sure to send around all the slides today to everyone who registered for this webinar. So, if you can't write this link down right now, don't worry, we will send this out after the webinar today. So I will stop there, and I'm going to hand it over to our first panelist, Perry Odie from Lakeshore. So Perry, please go ahead.
Good morning, Phil. Good morning, everybody. Thank you for having me today. Just going to pull up my shared slide here for my content. Again, my name is Perry Odie. I'm the transportation supervisor at Lakeshore Central School District. We're a relatively medium-sized district, approximately 2,000 students. We have 50 yellow buses on the road every day, twice a day, and we're located approximately 37 miles southwest of the city of Buffalo. I like to say some of the best white sands beaches on Lake Erie. But I'm biased, right? So I'm here to talk today with our superintendent, Mr. Daniel Pecos, with our transition into the electric school bus. We've been running an electric school bus for approximately 3 years now. We've acquired the vehicle through the truck voucher program and the VW settlement funds. So it is on a designated route for a disadvantaged community, which for us would be a school district in a school building in the town of Dunkirk. So we're to and from Dunkirk every day. It just happens to be our longest bus route for the day, and we're achieving approximately 80 miles on that route every day. It is a Generation 1 Bluebird Vision, and we can talk a little bit about the expectations that we've had for that vehicle and the actual outcomes, the reality of that vehicle in use every day. We added it to our fleet in 2022. Again, it's on our longest route, so we're charging it in the morning after it returns from its run and in the afternoon when it returns from its run, simply because it has an approximate 100-mile range on it. The second vehicle, battery electric vehicle we have in our fleet, was through voter referendum 2 years later than that, which is our vehicle 136, which we brought into our fleet. And because we didn't have any stipulations of where we had to run that route, we put it in the most heavily densely populated area of our district, simply for the fact that it's a clean running vehicle, zero emissions. Performance on our vehicles is strong. We're hitting expectations from the original manufacturer with our Generation 1 Bluebird Vision, our 2022. We're anticipating 100 miles range from the manufacturer, and we're achieving 87 to 90 miles range, depending upon our ambient mean temperatures. Of course, the winter weather does affect the charge time on the vehicle and does affect its performance on the vehicle. So we get a slight decrease in economy and efficiency in the colder temperatures. The coldest we've ran that bus to date is 17 degrees Fahrenheit, and we had approximately an 11% decrease in range based on the ambient outside temperatures. Of course, that is under full draw with heaters, windshield wipers, fan motors, things of that nature. And it's intentional. We wanted to see how the vehicle would perform in the colder weather. Some expectations we had from community. At first, the community was very mixed. There was a lot of negativity. People are very resistant to change, but we are educators. So we took the stance of let's educate our community, our first responders, our staff members on what bringing a battery electric vehicle on board as a fleet vehicle means for us. One, it means a decrease in expenditures. So the vehicles are less expensive to run fuel-wise than a diesel vehicle or a gasoline vehicle, approximately 2/3 the cost. They're less expensive to maintain. There's less moving parts. The preventive maintenance on the vehicle is quite a bit decreased compared to gasoline or diesel vehicles. And we let our community members know that. We brought our community members in. We had open houses, allowed community members to go for rides on the vehicles, experience how quiet they are, how smooth they ride, how smooth they drive. We've allowed staff members to train and drive them to get incorporated and just overall familiar with the vehicles. Staff training, there is a learning curve, no doubt. With anything new, anything you bring onto your fleet, you're going to have to train staff, keep them up to date, keep your technicians up to date, and keep first responders up to date. We did that with our inception in 2022. We brought all of our first responders in, showed how the vehicles function, showed how they're made, explained how to disconnect the high voltage systems, And we'll be doing that again with our current capital project coming to a soon close. We'll bring first responders in again, allow them to see our new vehicles, which are pictured here, newest vehicles being delivered throughout the next couple of weeks, and give them a orientation to our new charging systems, our new level 2 and level 3 charging systems. Questions always come up with insuring these vehicles. The insurance is a little bit more expensive. For us, we have not seen any significant increases in cost of vehicle insurance. We have everything full replacement value for our insurance here at the district. Keep in mind, a diesel school bus is going to cost the district approximately $175,000, whereas a battery electric school bus of similar size and seating capacities is going to cost approximately $475,000. So we do anticipate cost for insurances to be reevaluated as we become more predominantly battery electric. Utility coordination. So far, we've had great responses from National Grid, whom is our power supplier. To date, we've worked closely with National Grid, Fry Electric, IPL Electric, Capital Construction, as well as NYSERDA, the EPA, and other agencies to get a lot of work done in our district. To date, we've had one BTC dual level 3 charger installed and 2 level 2 chargers installed for our current 2 vehicles. We felt it was very important to have backup systems in place. Level 3 chargers regularly go into maintenance modes and update their communications, update their firmware. And if you have to charge a vehicle, it's important to have those backups in place so you could charge while your other chargers are updating or for maintenance or preventive maintenance. Future plans, which we're working with right now, we've redesigned our full-size bus lot, as you can see on the screen. We've actually worked with NYSERDA and the EPA for funding and actually redid the blacktop of the lot, any of the underlaying water and conduit for our charging systems. With that said, we're installing 21 level 2 AC chargers for our regular full-size fleet, and we're charging a 3-post Flex 180 charger for any visiting districts that may be coming on board or any fast charging needs that we would have throughout the day. All in all, when complete, will be complete by June 1st. We'll have the 21 AC, 3-post DC, and in addition to the 4 that we already have, 2 AC and 2 DC units. Questions or comments?
Thanks, Perry. That was fantastic. I think for questions, we will direct folks to drop those in the Q&A box. And I think we'll hold on questions there until the end. So please, if you have questions for Perry or for our next presenter, Varun, please put those in the Q&A box through the webinar platform. And we'll be monitoring those to make sure we ask some good questions from our panelists, from Perry and Varun, as well as the other folks from Lakeshore and NYSERDA who are on the call today. So next, we'll pass it over to Varun Adibatla from NYSERDA. Varun, please take it away.
Thank you, Philip. And I'm sharing my screen in a bit here. All right. You can see my screen. Yeah, thank you. Hello, good morning, everyone. Thank you for hosting. So we're an NYSERDA, and we'll be talking about how we're electrifying school transportation at our facilities in New York City. So by introduction, NYSERDA stands for the New York City School Bus Umbrella Services. We are 4 years in operation. We started operations in 2021. We transport 9,000 students with special needs, accountable to 18,000, close to 20,000 parents on a daily basis. Our fleet of 900 buses are expected to arrive at about 1,700 schools every day. And our fleet drives 40,000 miles across New York City, which accounts to about 9 million miles a year. We're staffed by 850 drivers and 850 attendants who form part of our workforce. So every bus has to have an attendant on board as well because of our special needs population. And of our 904 buses, 27 are currently electric, and we initiated electric fleet operations in September of 2024. And this is just a visual on how our fleet of yellow school buses paints the streets of New York City yellow every morning and every afternoon. This specific graphic is showing you how we essentially cover almost every street of New York City with our fleet of yellow school buses. So I do want to say thank you to all of our partners who have made this possible. We operate as a coalition in terms of realizing our electrification efforts. This includes a lot of folks from the left, the manufacturers of the buses themselves, the people who help with charging, and our site designer electrification, our utility, Con Edison. Thank you to NYSERDA as well for funding a lot of our infrastructure. And then there's a whole other set of folks here who constantly are part of this coalition to make this real and possible. So I want to start by talking about the key differences between an electric vehicle and an internal combustion vehicle. You know, my dad was a mechanical engineer. I'm a computer engineer. We didn't have a lot to talk about. Now we have a lot to talk about because we're constantly talking about the differences between how an electric motor and an internal combustion motor operate. And the big difference, I mean, the big thing with battery electric vehicle is that it's composed of a battery, it's fueled by electricity, it has a computer, and it drives motors, right? Compared to a gasoline vehicle that has a gas tank, you know, it's fueled by gasoline or fossil fuels, and then it also has a computer, which also drives motors. But where those similarities end there, the big differences between an internal combustion engine and the electric vehicles are how energy is utilized. So as you can see in the top graphic, for the amount of fuel that you put into an internal combustion engine, about 80% of that is lost. That energy is lost, and only 20% of that energy goes to the wheels. The electric motor, on the other hand, of the 100% of the fuel that's used, 90% of that energy that comes from the electricity goes into turning vehicles. So, I mean, it's not a matter of opinion, it's a matter of fact that electric motors are just more efficient than internal combustion engines and motors powered by them. So what's gained from going electric? First of all, there's no emissions, so better lung health for kids, drivers, anybody who's on the bus, anybody who's around the bus, because of the reduced NOx toxins, the nitrogen toxins, the carbon toxins that come out of tailpipes. That's not there in electric. Mental health, only because these buses are a lot more quieter. That's very important for our special needs population, who can be sensitive to noises and external noises and sounds. And so to have a quieter bus means ensuring a more comfortable ride for our population of children. And then lastly, what's interesting about the electric school buses is that they are a source for electric grid resilience. What that means is, in summer when the buses are not in operation, there's a real opportunity of plugging these buses into the grid through technologies like V2G or vehicle to grid. And that we are in the really big early portions of realizing some of this V2G. But that's the potential of operating an electric vehicle fleet, is that there's additional benefits, not just to the community and human beings, but also to our electric grid as a whole. Just to prove that point out by research and evidence, actually last year to the date, May 20th, researchers at the Harvard School of Public Health quantified the total benefits of replacing a diesel bus with an electric bus in a large city like New York City. And they were able to show that, in total, it was about $200,000 in total savings from climate and health savings per bus replaced. Okay, moving forward. So what's lost when going electric? Again, the big loss from going electric is maintenance. This is another thing that my dad and I keep talking about, is that, in the internal combustion engine, a lot of moving parts, as you can see in this figure over here. It's a very sophisticated piece of engineering. There's a lot of belts, fluids, sparks, and things that are going on in that internal combustion engine that has been perfected over the past 100 years. The electric vehicle motor, on the other hand, a lot simpler, almost very few moving parts except for the motor, not a lot of fluids going around there, not a lot of sparks going around there. And so the maintenance burden of the electric vehicle motor is a lot lesser than what you would have to do for an internal combustion engine. And a lot of our data has proved that out as well. And I think the previous presenter also validated that. And so that's good to know that, people who are going electric are seeing fewer maintenance work to keep these buses running more on the road. Yeah, the big thing, again, the previous presenter also mentioned that cold weather has, and that's the big change in transitioning to electric, is that there's, especially in a state like New York, we too in New York City see temperatures go down below 20, even below zero sometimes. And we've been collecting data about how these vehicles operate. And so what we found is that there's really two operating modes for these vehicles. One is a fair weather mode, like today is a fairly cold day, but for the past week it's been beautiful spring weather, and so our buses have been operating in fair weather mode. But this winter, when temperatures fall below 40 degrees in the morning, we switch to cold weather operations. And what that means is that we do things differently in the depot. The expectations of range definitely drop because more power is being used to heat the bus. What is interesting is how we change our operations in the depot. One of the things that we do during cold weather operations is we do something called we precondition the bus, which means that we are ensuring that the bus is heated from the charger itself, from power from the charger, as opposed to power from the battery. That way, the power from the battery, we're maximizing the amount of power from the battery to drive the bus, to move the bus, as opposed to heat the bus. That's kind of like our big thing that we do in cold weather, is to ensure that the bus is kept warm, and that energy that we use to keep the bus warm comes from the grid as opposed from the battery. Again, I think this has been mentioned as well by Philip at the front, is we have a long way to go. We have to electrify about 900 buses over the next 10 years, and we're about 2% of the way there. So, and so there's a long way to go here, and we're learning, we're sharing our knowledge with a lot of folks. As a nonprofit, one of our commitments is to not just operate this fleet, but also collect data and share that with our partners in the community at large. Okay, so this is excited to show you one of our depots. So this is our Zariga depot in the Bronx. This is a satellite image of that, and as you can see that real estate in New York City is very expensive, and so we make sure that we are utilizing every inch of that real estate. And so as you can see here, the buses are packed pretty tightly. And electrifying this depot means really the big challenge here is to figure out where chargers are going to be positioned. So our charging strategy is right now level 2 chargers, And I'll talk about what those chargers, what those different levels mean. But some of our challenges right now is to figure out how to charge these buses in the middle of the yard. It's easier to charge these buses along the peripheries of the yard, along the extremities. It's less clear as to how we'll be charging those buses in the yard. We're collecting new ideas every day, trying to figure out how to do that. There's mobile charging options. The technology is moving very fast. So we're very excited to test out different options of how we can electrify this depot. This is actually our Greenpoint depot. This is also a satellite picture. This is where I'm actually speaking from, Greenpoint in Brooklyn, even more packed and densely packed than our Zariga depot. And this is also a site of about 10 electric buses. Our Zariga depot has about 14 electric buses. And here too, the challenge is pretty severe as to how to charge these buses in the middle of the depot. So, real estate considerations are a big part of electrifying school bus operations as well. That's kind of the big point here. So one of the things that my team does, so I lead data science and I also help manage our electric fleet, is we're constantly collecting data. So as you can see here, we have a dashboard of our electric vehicle activity report, or EVAR. As of today, we've traveled 53,000 miles on our fleet of electric vehicles, and every mile driven on our electric fleet is a win. It's basically fewer asthma-causing toxins. Every mile driven causes fewer global warming emissions, fewer dollars spent on fuel. So that's an interesting thing that we've noticed, is we're spending, if those 50,000 miles were driven by gas buses and we were paying $3 a gallon, we would be spending about $17,000. Compared to that, we are comparing that to the price of electricity during off-peak hours. And so we would have spent $10,000 if we had charged these, but we're charging these buses overnight. So there is definitely about a 40% reduction in costs just from the price of fuel. Comparing the price of fuel. And some of these other charts here, we are measuring the efficiency of the buses by temperature. So, we are seeing one of the differences of a New York City school bus fleet is actually we have a lot more smaller school buses, of the type A school bus, as opposed to the larger school buses that you may see in Western New York or upstate New York. So our smaller school buses can sometimes the efficiency can be different. And so we've been monitoring those efficiency numbers here and see how they change with temperature. This data is open for the public to look at. It's also open for researchers to look at. We're happy to collaborate around data. Okay, I'll move through this a little quickly. So this is a battery. It's a graphic to explain how to think about batteries on these electric school buses. One of the things, as you can see in this graph, is that at least for this generation of buses, we ensure that the buses don't ever go below 20%, and that's to preserve the long-term battery health. 15% of the battery sort of goes away in heating during cold temperatures, 5% goes to idling, and then 60% of the battery capacity is actually meant for moving the wheels or for moving kids. And this bottom part here, that's the other interesting part about electric vehicles, is that because of New York City's traffic conditions and the stop and go traffic, there's a lot more potential for these buses to regenerate power. So we can regenerate up to 20% of power back just by driving in stop and go traffic. And that makes electric buses even better for an urban environment like New York City. Quickly, charging 101. So there's three types of charging levels. We predominantly use the level 2 chargers. And the way to think about charging levels is to think about how big of a pipe that you're using to actually feed electricity into our vehicle. So the DC fast chargers have the thickest pipe and the biggest pipe. The level 2 chargers, the ones that we use, have the slightly smaller pipes so they can charge to a certain speed. And the level 1 charger is the smallest that you'll find in residential applications. The other important thing that we do here is we do something called automated load management. That is in partnership with a company called the Mobility House, where there's a computer connected to our chargers to orchestrate charging to ensure that we're not pulling too much electricity from the grid. It also allows a level of flexibility and automation into our charging to help us save money. So that's what we do on charging. I'll end by in the next 3 slides here by saying one of the things that my team, the data science team, does at NYSERDA is that we are pre-planning our routes to ensure that any driver who's an electric vehicle never has to be worried about range on the electric. So we are doing a lot of pre-planning prior to assigning an electric vehicle to a route, where we want to ensure that the drivers on these buses never have to be worried about losing energy from the buses. The other important thing that we do when we assign electric buses is maximize their access to disadvantaged communities. Let's clip this slide, but the disadvantaged communities is a map that's published by NYSERDA. They did a lot of important calculations to understand which communities have been historically exposed to pollution. And as you can see here in New York City, much of the Bronx has been designated as a disadvantaged community because of its historical exposure to highway traffic and pollution. And so we want to make sure that our electric fleet is doing routes as much as possible in disadvantaged communities. And in order to do that, we have NYSERDA also requires contractors to prepare fleet electrification plans. We're building tools to help other school districts help electrify and think about how they can electrify. So we built a tool called eReady that helps any school district essentially draw their route on our tool and see how feasible it can be for an electric vehicle, given the temperature and given all those different conditions that the vehicle may be subject to. So that's my last slide. This is our team. Matt is our CEO. We have a fantastic leadership team. We also have a fantastic IT team that helps us keep these electric buses running and healthy. So thank you very much.
Great, thank you, Varun. I think now we will use the remaining time for some Q&A from the audience. So we've got some questions coming in. We also have some of our own questions here. So I think you both covered this to some extent, and Perry and Varun or others, if you want to come on camera, that'd be great, just so everyone can see our panelists here. But you both mentioned that, how your buses are performing in cold weather. So, just coming out of this most recent winter, I know you didn't see, Perry, I feel like you didn't see a huge drop in range, but can you just talk about maybe what you were expecting going into the winter versus how the buses performed? And, was there anything you did proactively to address that you felt worked well?
Absolutely, Phil. So preheating is extremely important for battery electric vehicles. When you preheat, as was explained in Varun's presentation, he did a very nice job, by the way. When you're preheating that vehicle, all of the energy that is consumed for heating the interior of that vehicle is from shore power. So that comes from your charger. It doesn't come from your high voltage battery systems. And that protects the longevity of that battery and the ability for you to maximize range. So preheat the vehicle, keep the interior warm as possible. When you're utilizing the vehicles in the wintertime, I always anticipate 80% of that battery being reachable when en route with the type of buses that we're running. But it's all on driver comfort and passenger comfort. So the way that the vehicles are made that we're using with the Bluebird Visions, there's onboard heaters that heat the coolant which runs through the batteries. So you can heat up the coolant in those batteries, which helps to heat the interior of the bus, the passenger compartment, and your windshield defrosting system. You could heat that coolant up to a certain temperature and then turn the heater off. And that coolant will continue to heat the interior compartment, passenger compartment, and keep your windshield clear while you're driving. So you could maintain the temperature without continually heating and drawing on the high voltage system. So, and that comes from driver comfort and educating the driver and educating the bus attendants that are on board the vehicle how to use it.
Yeah, and I'll add a comment. Thank you for that, Perry. And I thought your presentation was really great as well. I'll add that in addition to ensuring preconditioning or preheating the buses, insulation, making sure that the windows are tightly sealed so that there's no heat loss. That's really important as well. So we do a lot of pre-trip inspections to make sure that the windows are sealed up tight. Tire pressure has an interesting, we haven't put the numbers yet to some of this stuff, but tire pressure has an important relationship to range. So making sure that the tires are filled adequately to basically squeeze out as much efficiency of the from the bus as possible. I think those are the other 2 points that I'll add to what Perry already talked about, is preconditioning the bus.
Great, thank you. And Perry, since you brought this up, on the staffing side, can you each say just a bit about how you've approached training your staff, maybe what concerns they've had or challenges they've had as they learn about the new technology, either on the bus side or the charger side?
Absolutely. So year number one, 2022, when we brought the first battery electric bus on board, large learning curve. The OEM and New York bus sales helped us out a great deal on training drivers on how to utilize the controls on the bus, how to utilize regenerative braking, how to charge the vehicles. They helped us out a great deal on training the first responders on how to disconnect the high voltage systems, how to disconnect the low voltage systems, how to tow the vehicle if involved in a motor vehicle accident, and how to incorporate a battery fire or a low voltage electrical fire on the bus. They also helped us train our technicians on how to perform preventive maintenance systems on the battery electric vehicles, which are very, very similar to a gas or diesel vehicle, but they incorporated into that education the high voltage end of it. Just because a high voltage system is a 600 plus volt system doesn't mean we cannot work with parts of that high voltage system. So the training for our technicians had to go above and beyond what they're accustomed to for diagnosing diesel and gasoline vehicles. We now have to educate them on the high voltage systems, protective personal equipment for working with high voltage, and some of the items they can service here in the shop instead of going back to dealerships or original equipment manufacturers. With that said, one item that we brought on board in year 2 and year 3 of operating the battery electric vehicles, how to maintain and how to perform preventive maintenance on the chargers. There's actually, in my opinion, a greater level of severity or seriousness with the charging systems and the complexity of the level 3 chargers over level 2 charging systems that you have to maintain. These vehicles are extremely complex. They have a lot of electronic components in them, a lot of computer components in them. You have to watch for moisture, humidity, heat, cooling, and you just have to be knowledgeable of how to take care of that charging system. Fortunately, at Lakeshore, we've coupled up with some very strong partners. One, Cummins Incorporated, that can help us with that charging maintenance and education of our staff members how to maintain it. But it was a long toll to get that partnership established. So when we first started out, we were working with a provider where as soon as we were awarded EPA grant funding, that provider was no longer in business. And we had to pivot very quickly to hook up with a partnership with a reputable corporation that would see us through not only this leg of our journey for transitioning to electric school buses, but for future projects.
Yeah, and thank you for that, Perry. I think in addition, I mean, I agree with 90% with what Perry talked about from a staffing perspective. The additional thing I'll add is, in addition to the trainings that we received from the OEMs, we also needed to make sure that a lot of Spanish-speaking training was provided because a lot of our technicians are Spanish-speaking individuals themselves, and so it's easier. It's just a way to communicate technical knowledge in a way that's easier for them to absorb and get them more confident in working with these complex systems. The other thing I'll add is just the level of integration between the IT team. So NYSERDA has invested in its data infrastructure and its IT infrastructure, and making sure that the IT team is talking to the fleet team, because really these electric buses are computers on wheels, right? And they require 24/7 monitoring. And my background is in cloud operations and bringing that perspective into managing a fleet of computers on wheels has helped us understand how to deal with that complexity at scale and also scale up that complexity. Lastly, I'll say is that our depot staff do a fantastic job in making sure that these buses, during cold weather operations, they're connecting them to the charger and starting up the heat and preheating the buses. There have been some advances to do remote preconditioning, so essentially remotely start the heating or the cooling of the bus. So that's interesting for us. But yeah, in terms of staffing for the transition, I would say that making sure you have folks on at least your staff or your partners who understand the complexity and the digital complexity of the bus, and be able to manage that digital complexity as you scale up.
Could I add one point on staffing? Sorry, Matt. Could I add a point on staffing? One thing that we've noticed, like many other school districts in New York, we have a driver shortage right now. But Perry has actually experienced something that we didn't expect. Several of our bus attendants, after riding on the electric buses, have expressed interest in getting their CDL license and becoming a bus driver. And Perry has trained them and successfully gotten them behind the wheel driving buses because they want to drive the electric buses.
So those of you who saw me run it and just check with Varun to see if I can contradict him. I do want to also say, so, I'm not sure who's here, but, NYSERDA operated 3 electric buses, frankly, before Varun started. These are computers on wheels, and we think operating a fleet of a lot of electric buses is complicated, and probably more complicated than operating a fleet of a lot of internal combustion buses. But we very successfully operated 3 electric buses with a lot of support from the dealer. They came and provided some training. We bought 3 inexpensive chargers, frankly, from Amazon, and we put them on the wall. We had an electrician put in some 240-volt outlets for it, and we did just fine with them. So I would hate to scare people into thinking that. And I think it is going to change our industry to be operating these. And Varun's exactly right. These are computers on wheels, and there's a lot of change that is happening. But it would be a shame to scare people from taking the first. I mean, getting a few buses, putting some chargers on the wall, plugging them in and using them, having a good dealer relationship when something related to the electric bus goes wrong, but knowing that you can still change tires and put windshield washer fluid in the bus it's really important to know that you can operate a few buses just like you operate an internal combustion bus, but in fact they're quieter, they're less polluting, you're getting experience, and as we saw, you're saving money every day.
Yeah, that's excellent. Thank you both. And Dan and Matt, while we have you both here on the line, we're getting some questions about community support. We know that electric school buses can divide the room sometimes. So in your communities, what are you hearing from people about the buses? Are there things you're doing to either, win over support or answer common questions or concerns people might have?
Sure. We were lucky that we actually started looking at the electric buses before they were mandated. We have very good support of our school board. We had a school board member that was on her 2nd or 3rd Prius with, I like to say, 6 million miles on it or something like that. And when Perry and I first started talking about, we should get an electric bus and try it out, the board was supportive, but Perry kept telling me, tap the brakes, hold on, the technology isn't there yet. And we were waiting, and then he finally said, I think they're where the technology needs to be. We can try one out, and then COVID hit. So we had to put everything on hold because we were applying for funding through the New York Truck Voucher Program. And we didn't put enough miles on the bus that year because of the COVID shutdown period. So we came back after COVID, applied for the grant, received it. And Perry mentioned we routed through the city of Dunkirk, our longest bus route in the district. So everybody tells you, get one and try it on your shortest route. We did just the opposite. We figured if it'll work on the longest route, it'll work on any of our others. But we're lucky that our community, I won't say we didn't have naysayers, but we have a tremendous amount of support in the community. In fact, voting on our annual budget is going on right now as we speak. But our voters gave us the authority to spend the additional money for the bus above and beyond the grant amount, and supported it, and have supported several buses since. And I will say Perry successfully applied for EPA funding, and we're waiting 20 full-size electric buses right now. We've taken delivery of the first 3. You saw that bus parking lot that we're reconfiguring. As soon as those charging stations are commissioned this week, we'll take delivery of the other 17, and we'll be almost 50% of our fleet converted. So we've had tremendous community support. We have reached out to other neighboring districts in the area where they didn't have successful votes. And one in particular came back and now got a successful vote second time around. Because what we're finding out is all the negatives that are out there, that they're too heavy, that you can't go over all your same bridges, that your bus lifts aren't going to work, that those are all wrong. It's just misinformation out there. Our buses are about 1,250 pounds heavier than the diesels. Our lifts work just fine. We don't have to reroute them anywhere. Actually, one point I did want to make about the winter driving with these, our bus drivers find that they handle better in the snow because of the weight displacement. With the batteries being under the passenger compartment, the weight is more evenly displaced over the entire bus rather than the engine sitting over the front wheels that are not drive wheels on a internal combustion bus. So there's a lot of positives that actually combat the negative information that's out there. And once our community found that out, they were a lot more accepting to them.
The only thing I'll add, I mean, Dan, those are great stories. And I just reiterate especially the things about the myths that really just aren't true, is, we had maybe some resistance from some of the mechanics that work here who might have been from a generation who didn't, and we simply kind of plowed ahead a little bit, right? We started a little bit slowly. And what we've learned is that, kind of the grisliest old mechanics who love their diesel buses and have all sorts of reasons to kind of, they sort of get that not only is this the future, and not only do they want to make sure kind of the younger folks kind of learn this, but they're kind of interested. So I guess I wanted to say that we've been lucky that in New York City, we have a mandate. So community response has been less of an issue, but we've really seen with ourselves that once people are exposed to these, they really kind of get excited. Both the young people who see it as the future, and even sort of the folks who are thinking, well, I've got 5 more years left, but this is really cool.
Excellent. Thank you both. And we do have a large number of questions coming in, so we may need to put together some sort of Q&A document or something following the webinar. So we will work on that on the NYSERDA side, just because we only have about 10 minutes left here. But we do have plenty of questions coming in, and as Dan noted, there are votes happening across the state on school budgets today, or school district budgets. So that will have an impact for whether some districts are moving forward on electric school buses or not. So we're eager to see the results of those votes across the state. One question I wanted to make sure we touch on is working with your utility. So, we know districts need to work with their utility both to plan for charging, also to make improvements to bring additional power to their site. So if I was wondering, Varun and Perry, could you share a bit about, what it's been like working with your utility? Have there been things that were a smooth process, things that maybe were more challenging or took more time, and what, how you're working to address that with your utility?
I can definitely speak on it. Mr. Pecos may be able to do it better than I, but I can certainly start the conversation. We have National Grid. National Grid has been fabulous from step one. When we dealt with the administrative levels from National Grid, they came out, we did a fleet electrification study and a supply study of all of the supplies that we have coming to our transportation center. We're fortunate where we have two separate parking areas for our fleet. 50% of our fleet is 71 passenger conventional school buses. That's in one lot. The other part of our fleet is 30 passenger type A vehicles, which is in another lot. Both of those lots have separate services. So on one strand, we had enough energy to energize our full-size bus lot, but we would have to have a second service added for our type A bus lot, which we'll be having in future projects. So right now we have half of our fleet, 25 full-size buses running off of National Grid. They were good to work with. They helped us with funding for Get Ready program. We had many conversations. They actually had representatives come out to our OACM meetings and planning meetings and budget meetings to work with it. And Dan, if you want to add anything on that, you're more than welcomed.
I think you covered it well, Perry. Thanks.
Yeah, and I'll add that we've have a very close collaboration with Con Edison. We've recently just enrolled in their Smart Charge commercial program, which ensures that our fleet, we are only charging during off-peak hours, and we're incentivized. We're realizing financial incentives to do that, to make sure that those daytime peaks are avoided as much as possible. We're also enrolled in other aspects of the Con Ed's program that help pay for a lot of this infrastructure in front of the meter, as well as the labor that goes into this, into essentially instrumenting our facilities with charging infrastructure. So Con Edison has been incredible in supporting us and also helping us with resources and their applications as well. Given a regulated utility, there's a lot of their applications can be very dense and have a lot of steps, but we've always found a human being on the other side to help us navigate these processes.
Great, thank you. We're also getting a lot of questions about, the specifics on the charging side. So, have you been able to meet your charging needs with overnight charging? Are you needing to fast charge in the middle of the day? What sort of challenges or solutions are you looking at on the charging side to make things a smoother process?
Yeah, I can go ahead, Perry, if you'd like to go first.
Charging, we try to come up with any configuration we can to keep charging as slow as possible for battery integration. Degradation, sorry. We're very careful when we're using the fast charging during the daytime. We fast charge when we have to. We try to, during the day, we'll never use more than 100 kilowatt fast charger. But if we have the time, we wean that back to 30 and 40 kilowatts per hour for charging, simply because of demand charges are very high during the day. The majority of the time we can efficiently recover all of our charge necessities through 19.2 kilowatt hours, charging on off-peak times. So we try to gear everything for that off-peak overnight charging. The longer we can stretch charging out, the better the incorporation between the bus and the charger are, and the more we can control the level of charge demand on that vehicle and the demand on our resources.
Yeah, and for us, because all our fleet right now is type A, which is the smaller school bus, Those currently the generation of buses that we're using have 88 kilowatt hour battery sizes, and they can accept energy at 13 kilowatts per hour, which means a charging period of 6.5 to 7 hours, right? And using a level 2 charger, right? And they are capable of doing DC fast charging. Right now, we don't have any DC fast charging. As Matt said, literally the first thing we did was go to Amazon and buy an off-the-shelf charger, and we were fine charging these buses on an overnight schedule. So we plug them in at 7 p.m. and by 3 a.m. they are 100% ready. And the additional partnership with the mobility house, that they do is the automated load management. Is what they're doing is they're connecting that computer to the charger. And so what that allows us to do is, even though the grid is supplying so many kilowatts to our facility, we are able to kind of spread those kilowatts in a way that we can take on more buses. So for example, we can have 10 chargers that are rated at 19 kilowatts, but because they're software controlled by this computer, they will never go above the grid limit. And so that's been a very innovative and unique partnership with the utility, Con Ed, where we last year we won an award called the Most Innovative Interconnection Award, which is the geekiest sounding award there might be. I mean, I might say we might get the Flux Capacitor Award next year, but no. All jokes aside, that's what Matt is showing the award right there, and that speaks to this ability to connect these chargers to a computer so that they're trickle charging. I think the easiest way to understand this is look at a farm, and if you had like a bunch of vegetables, you're trickle charging, or you're watering those vegetables like trickle irrigation. The same way we're trickle charging our buses to make sure that they're fully charged by the morning.
Great, thank you. And we are just about out of time here, so first I want to thank all of our panelists for joining, answering these questions, sharing their presentations. And then if any of you have final thoughts or anything you wanted to mention that we haven't covered yet, please go ahead and give some last thoughts here before we wrap up.
I did want to mention, they did speak about the quietness of the ride. We have noticed a great reduction in the amount of discipline referrals for students because it's a much calmer bus ride. We are getting our first mini bus, and we are going to try see how our special needs students on that bus run like the quieter run. But so far, our students far prefer the quieter run, and we didn't anticipate that.
Yeah, and I'd say my closing thoughts here is that these current generation of buses are lithium-ion buses, and the battery chemistry is changing so rapidly. There was a question about charge degradation in the batteries and the life cycles of the batteries. Yes, there has been some research that shows some degradation in the battery life over the span of 8 years. That research is for lithium-ion batteries. The next generation of batteries, which are lithium-ion and sodium-ion batteries, these batteries have shown a lot more resilience and a lot more longevity and durability. So I think a lot of these concerns around range and degradation have been addressed by the next generation of battery chemistries out there.
Well, if I could just make a closing comment. Thanks for having me today. Great panel. Really appreciate it. I just want to reassure everybody, battery electric's something different. It's not scary. It's actually very, very simple to work with. It's very simple to use. Take the time to do your research. Get one on fleet. Use it. Enjoy it. They're very simple to work into training, and make sure you partner up with the right people. There's a lot of really intelligent people out there. Team up with them. You'll see a lot of people coming out of the woodwork every time you want to buy a charger, but do your research, stick with people that have been around in the industry for a long time, and you'll have a very simple transition.
One other point we didn't mention on the maintenance, Perry told us something earlier this week or last week that was kind of astonishing to me. Our bus that we've been operating for 3 years. So far, he's put one $11 part into that bus, and it's still operating with 45,000 miles on it, still operating with its first set of brakes. I think that's phenomenal.
That's fantastic. I'm glad to hear that. So we are at time, but thank you all again for joining us. Thanks to everyone who attended the webinar. We will share the recording and slides with people who registered for this, and we will do our best to find a way to get to some of these questions that we were not able to answer live on this webinar. But thanks again to everyone for joining us, and we look forward to seeing you again at some point in the future.
Thank you.
Thank you.